today, guys, I am going to go over some vocabulary terms with you that we're going to be using in Unit 12. Okay, now some of these you've heard about before, some we're going to elaborate on them and add some extra stuff to it that you may not have heard about before. So let's take a look. Okay, so this is part of your Unit 12 vocabulary, the notes. Okay, it says we're going to be dealing with the three-dimensional solid. A three-dimensional solid has length, width, and height. We're going to get more into that as the unit goes on. But what I want to focus on is a polyhedron. Okay, a polyhedron contains faces, edges, and vertices. Okay, now let's talk about what all of this is. Okay, so guys, right here, I have a polyhedron. This one is a prism. Okay, well, hey, look, this one is a pyramid, right? Now, when we look at this, we talk about they have faces, edges, and vertices. So faces, guys, that's this flat part right here, okay? The face. The edge is where two faces intersect. And the vertices, okay, that is a point, right? It's where the edges intersect. Now, this right here is a cylinder, and right here we have a cone. These are not polyhedrons, okay? And the reason why is, guys, they don't have any flat surfaces. They don't have any edges, okay? This is a curved surface, okay? So it is not considered a polyhedron. Okay, so let me ask you guys. Dun, dun. Is this a polyhedron? Yes or no? Okay, what about this guy? Is this a polyhedron? Okay, what about this guy? Is this a polyhedron? Okay, so let's see how you did. First of all, yes, this is a polyhedron. And yes, this is a polyhedron because they have flat surfaces, right? They have faces. Okay, this, by the way, this is a hexagonal prism. I'm going to talk more about that in just a little bit. This is a regular pyramid. I'm going to talk a little bit more about that in a little bit. And this one, now, this one was not a polyhedron because it is a cone and it has a curved surface. Okay, it only has one flat surface. That does not make it a polyhedron. Okay, let's continue on. Let's look. Okay, so, guys, some of you may have seen these particular shapes. Now, these are called platonic solids. I just want to point these out. Okay, platonic solids are polyhedrons with faces that are all congruent regular polygons. Do you guys remember? A regular polygon has all congruent sides and all congruent angles. Okay, so if I look at well, I'm going to call it a hexadron, but really, we know it as a cube, okay? All of these are regular quadrilaterals, squares. They're all congruent. So a cube is actually a platonic solid, right? Now, some of you might recognize these shapes from different shapes of dice that are used like in Dungeons and Dragons. And yes, I have some cool dice like this too, right? As a matter of fact, I have one of these that has a dice within a die. Woohoo! Yes. So, yes, I know I get so excited about these things. All right. So guys, let's go down and take a look at the rest of this vocab and let's elaborate on some of these shapes. All right. So you guys have heard about prisms before, right? And remember I told you we were going to elaborate on that hexagonal prism I showed you just a second ago? Okay. So first of all, a prism is a polyhedron with two congruent parallel bases, okay? So that means that, and I'm going to get up bigger here, this base right here and this base right here, they are parallel, right? They're never going to intersect. They're parallel and they're congruent, okay? Now, the parallelograms that connect the bases, I call this the space between the base, right? The space between the base, these are called the lateral faces. And right here, this is called the lateral edge. Okay, now recognize, guys, right here, I had this lean sideways. A base does not always have to be on the bottom, does it? Okay, so bases are parallel and congruent. And in a prism, you will have exactly two bases, no more, no less. In a prism, you will always have two bases. Now, prisms are named by the shape of their base. So I just said that this was what kind of prism? Yeah, this one's hexagonal. Okay, all right, well, what about this one? Ooh, now let's look at this one. Okay, this one has, wait a minute, this side down here could be congruent to this side, and they're parallel. But wait a minute, the front and the back, oh my gosh, and this side, we could have multiple different kinds of bases in this one, can't we? Okay, so guys, typically this type of prism is called a rectangular prism. And whenever you see one like this, you want to default that, yes, this one actually has all kinds of different ways that we can do the bases, but the base, you want to default that the base is on the bottom. Now, that's only with a rectangular prism. Okay, well, let's say, if I said that this is a prism, well, if I name it by the base, then what kind of prism is this one? Did you say that this one could also be a square prism? Yes, okay, because we have squares on each side, so it's a square prism. All right, y'all ready for this one? Dun, 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 dun. Okay, so what would be the name of this prism? Okay, hopefully you said, Miss Smith, that's a triangle on one side, a triangle on the other side. This is a triangular prism. These two bases are congruent and parallel, right? Okay, so you guys see how we're going to name these prisms. You name it by the shape of the base. Now, let's kind of elaborate on how do we figure out the height of these guys. Okay, so first of all, guys, right here, a regular prism means that the bases are regular polygons. You guys remember the regular polygons? Some of you going, oh, crap. Yeah, I remember that. Yeah, you guys remember the regular hexagons, right? Now, the height of the prism. Do you guys remember I just said something here just a second ago? Okay, I said that I consider the height of the prism is the perpendicular space between the base or the space between the base. Okay, so the space between the base. So the height of a prism, okay, and I'm going to come back up here for just a second. The height of a prism, the space between the base. So the height is right here, isn't it? Notice the height does not have to go vertical with prisms, does it? Okay, can it? Yes. Okay, so the height is the space between the base. All right, now we have something that is differentiated. It's called a right prism and an oblique prism. A right prism, guys, that's just like a building, a tower, if you will. It's standing straight up and down. An oblique prism, okay, the lateral edges are not perpendicular to the bases. Okay, they are not perpendicular to the bases. So that just means that it leans. But the height of a right prism and the height of an oblique prism will still be the same because the height is still the space between the base. And we would measure it with a perpendicular line like that. Okay, so the height would still be the space between the base, but you measure distance or the height with a perpendicular line. Do you guys remember before I said that the height and the base will always, always, always be perpendicular? Okay, so this right here would represent the height of that particular oblique prism. Okay, let's go take a look. Dun dun. Let's go down and take a look at the next page of the notes and let's see what our next shape is. All right, y'all, our next shape is a cylinder, right? Okay, so a cylinder. Let's think about this. A cylinder, and I'm going to bring it up here. A cylinder has the curved sides, but guys, it still has two congruent and parallel bases. They just happen to be circles, don't they? Okay, so the height of the cylinder is still the space between the base. Okay, so now think about it. in a circle, remember, we're going to be dealing with radius that goes from the center out to the edge, and we're going to be dealing with diameters that go all the way across. Okay, now why I point this out is because you need to know the radius and the height, okay, in order to find the surface area or volume of a cylinder. Okay, all right, so let's go look. Okay, now I want you guys to look right here, a right cylinder and an oblique cylinder. Yes, we are going to have those as well. Okay, I want you guys to think about this. A right cylinder would be like a can of soda, right? Or a can of soup, okay? Can you guys think of any real life oblique cylinders? What do you guys think? How many of you guys said the Leaning Tower of Pisa represents an oblique cylinder? Okay, so, and guys, just like with a prism, an oblique cylinder, the height is still going to be the space between the base, and right here, this would also be the height, wouldn't it? Okay, so remember, height is going to be perpendicular to the base. Okay. All right. Hey guys, can you believe that really that's all there is to cylinders? But what's next? Well, hey guys, what's next is a cone. Okay. Now, most of you, when you think of a cone, you guys think of like an ice cream cone, don't you? Okay. So guys, with a cone, there's something that I want to point out to you guys. Okay. So we have this cone right here. And I can turn it upside down. I can turn it sideways. It doesn't matter. It's still going to be a cone, right? Now, the height of the cone, we don't have another base over here. So the height of the cone is the space between the vertex and the base, okay? It doesn't matter if it's sideways. It's between the vertex and the base, okay? So when we find the height of a cone, and this is true for pyramids too, okay, it's between the vertex and the base. Now, there's something that's called the slant height of a cone and a pyramid. Hey guys, slant height is just that. Remember I told you height is perpendicular to the base, but slant height is going to be slanted. So slant height is this height right here. Okay, this height right here. And I'm going to show you guys here something in just a second. Now, cone. Okay, a cone, the base is a circle, which means we're going to be dealing with a radius, aren't we? Okay, so let me show you guys something cool with slant height. Okay, so, and I'm going to zoom in right here. Okay, so slant height and the radius, okay, form something. Here's our regular height. Okay, that's the height. Okay, here is the slant height right here, and here is the radius. Hey, guys, in a cone, do you guys notice that, hey, now we have a right triangle. And if we have a right triangle, hey, we can use trigonometry or we can use the Pythagorean theorem to find some measurements. Okay, and yes, you might be doing that. Okay, all right, and just like we had an oblique and a right prism and a cylinder, you might have an oblique cone as well. Okay. All right, last but not least, dun, 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 is our pyramids. Okay, now, most of you, when you guys think of a pyramid, well, don't we think of the pyramids in Egypt, right? And the pyramids in Egypt are regular pyramids, okay? So if you guys see, this is a regular pyramid. The base is a square, isn't it? Most of the time, this is what we envision when we talk about pyramids. But hey guys, look, this base is a triangle, but it's still, if I don't drop it, it's still a pyramid. So this is a triangular pyramid. And as you guys will see in our notes, we can also have a hexagonal pyramid. Okay. Now, guys, with a pyramid, we are still going to have lateral faces. Okay. The lateral faces are going to be right here. Okay. Now we're also going to have lateral edges. That's right here. Okay. And we're going to have height, which goes from the vertex to the base. And we're going to have slant height. Now slant height, it goes down the side of the face. Okay. The slant height goes down the side of the face. It does not go down the edge. It goes down the face. So I want to, you guys can write something on here, okay, when we talk about slant height, okay? And let me get out my handy dandy pen. Okay, slant height, which is right here. I just highlighted that, okay? So slant height, okay, and let's see if I can write today, is always on the base, or always on, excuse me, a face. Slant height, always on a face. And I have, there we go. Now you guys can see it. The slant height will always be on the face, okay? It will not be on an edge, okay? So again, I could draw in, if I went down, this side right here, okay? This blue line, it's perpendicular to the edge, okay? But it goes down the face. That is slant height, okay? That's another way to look at slant height. Now, regular height. I'm going to highlight regular height. Regular height goes from the vertex and it goes down to the center of the base. Okay. Oh, hey guys, check this out. Look, the slant height, the height, and wow, this purple piece. What would that purple piece be called? Hey guys, do you guys remember, dun dun dun, the apothem? Do you guys remember that? The apothem. Okay, so I'm going to talk more about that, but that makes the slant height, the height, and the apothem also makes a right triangle in a pyramid. Okay, so where it was the radius that made the pyramid and the cone, it's the apothem that makes the right triangle. I said pyramid and a cone. Oh my gosh. Guys, seriously. Okay, that makes the right triangle in the cone. It's the apothem that makes the right triangle in the pyramid. All right, so, okay, I want you guys to notice right here. There is something else that I want you guys to, okay, notice, and I'm going to highlight this. Slant height, okay, slant height of a pyramid is also called lateral height, okay, because it is on the lateral face, okay, so the lateral face. Okay, you can have a right pyramid, you can have an oblique pyramid, just like, have you guys noticed that all of these shapes can either be right or oblique? Yes. Okay. All right, we have one more page. Y'all ready for this? Dun, dun, dun. Spheres. Okay, spheres. Okay, now, some of you, all of you probably know spheres, don't you? Okay, so spheres represent basically a circular figure, right? Now, the radius of a sphere, I want you guys to notice something. The radius of a sphere can go from the center to any point on the sphere. Okay, so, hey, have you guys ever touched, like, you know those, they're like electrical, orbs, and you touch it and the lightning comes out from, oh yeah, there it is, from the center out to the edge. Hey guys, that lightning really represents what a radius can go anywhere, right? It can go anywhere around the sphere as long as it originates from the center. Okay, now the diameter of a sphere, okay, the diameter has to go through the center, but a diameter of a sphere, guys, a diameter of a sphere can also go like this, can't it? As long as it goes through the center. Okay, now there's something else that's called a chord, and you guys will, I think you guys remember this just barely. We touched on it when we were doing circles. Okay, a chord simply goes from one side of the sphere to the other. Okay, so we are not going to do a whole lot with chords, but I want you guys to notice that it is there. Okay, how does this play in? The great circle. Okay, guys, the great circle of a sphere is basically what we would consider the circular base of the hemisphere. Okay, so hang on just a second. Let me go get out one of my little hemispheres and my spheres, and I'll show you guys what this looks like. All right, guys, I have my sphere right here, and I know that it's kind of hard to see because it's clear, but a great circle in a sphere simply goes around like what we would call the equator, right? So, and you guys can see this is my little hemisphere, right? It's half of the sphere. So the great circle would be considered the base of the hemisphere. Okay, so again, this is just a visual representation of what the great circle is. Okay, now, guys, if we go back and we look, Okay, if you guys look, it says the volume of a hemisphere is half the volume of the entire sphere. And the surface area of a hemisphere is half the surface area of the entire sphere plus that circular base, which is the great circle, because everything on the surface is surface area. Okay. All right. So guys, we went and we talked about a whole bunch of things. Okay. A bunch of vocabulary. So when you guys are looking at your assignments throughout this particular unit, keep these notes handy because you may need to reference back to them to notice the parts of all these particular shapes. All right, I'll see you guys in the next video. Until then, adios.